everyone. How's everyone doing this morning? Good? Awesome. So how many of you guys actually, are familiar with Tezos, have heard about it, read about it? What's the extent of knowledge in the room here? Okay. So the start of this presentation is more of kind of like an overview of where the ecosystem's at today, how the baking ecosystem looks like, how the on-chain governance process works, and then, I'll give it off to Michael just to kind of like go on the actual workshop. But I want to make this as interactive as possible, so please interrupt me, ask me questions, etc. So as I mentioned, what we're discussing today, I'll give a brief introduction to Tezos. We'll talk about the value of tokenizing assets on Tezos 2, the big value prop, in contrast to some other chains, etc. The asset standard, FA 1.21, and then Michael will dive into the actual workshop. So what is Tezos? I'm sure a lot of people here in this room already know what this is. Tezos is an upgradable smart contract platform for assets and applications, right? So it uses the liquid proof of stake consensus algorithm for block publishing and endorsement, as well as the allocation of governance rights based on stake. And this stake is measured in roles, which can also be coined as a deposit of around 8,000 XTZ. So it also uses an on-chain multi-stage governance mechanism, which is truly beautiful, which reduces the iteration time and increases coordination of all parties, right? So through this formal governance process, the Tezos network can actually upgrade itself, right? And most important, Tezos is actually a meta governance protocol, right? A meta protocol. So the actual rules themselves of consensus and the rules of governance themselves can also change, right? So if something's not working, I think behind community signaling and sentiment, the network can upgrade itself. And we'll dive into the actual system and how that works a bit. I'll give a very brief overview. But what does the current baking ecosystem look like today? So that we have over 470 bakers across 34 countries, 6 different continents. As you can see, a very, very active ecosystem all over the world. Of course, many flavors of baking, everything from ledgers to Raspberry Pi, etc. 117 of these, probably a bit more now, are actually public delegators. So these validators run baking operations where they actually are vying for the stake of delegators and usually charge a small fee in return, depending on their performance, etc. These are trusted entities, right? Delegators actually have to trust that these validators are going to run a safe, secure, and efficient operation, or if not, I wouldn't delegate my XTZ to them in the first place, right? Currently, about 71% of the total supply is actively baking. That's around 80%, total supply, 80% of the active supply in the network. That's as of July, so that probably has to be updated. It's probably a bit higher now. So when we talk about liquid proof of stake specifically, liquid is a term that kind of hasn't been coined as much outside of the Tezos ecosystem. Of course, it's been floated around, but the LPOS system actually allocates baking and so block publishing and the endorsement of those blocks for consensus. So it's liquid because any user can actually delegate their baking and governance rights at the moment to any other user to participate in consensus without the risk of actually being slashed, right? Or without actually having to put up that bond, that initial role. So it has a flavor of DPoS like you would see on EOS, on Tron, or whatever, but it's completely different because it's actually liquid. And baking itself is actually incentivized by inflation. I think something we see a lot in this space is the confusion of inflation with yield or returns. Again, this is inflation that's diluting the entire network, right? So the inflation rewards to the bakers are actually, the incentive mechanism, but are not yield for the actual delegators in a sense. Currently, this is targeted at a 5.5 inflation rate. It's closer to 7% just based on the percentage of active supply that's actually staking on the network. Some other quick details about proof of stake, about the liquid proof of stake. The protocol randomly assigns baking and endorsement rights to the roles themselves, so to that deposit of 8,000 XTZ. Used to be 10,000 before the Athens upgrade. We'll dive into that a bit later. The original consensus algorithm is ME, which is now ME plus after Babylon 2. We'll also dive into that later. And instead of the actual, the longest chain being the one with the most work, it's actually the fittest chain. So it's based on most endorsements to the chain that actually decides which one's the longest, right? So a bit different than some other chains. And it obviously uses the bonds and slashing of double bakers to prevent the nothing at stake problem, which I'm sure everyone here is familiar with. The smart contract language itself, Michelson, was designed for short, simple contracts and designed for formal methods and formal verification. But we also have higher level languages like Lego and SmartPy, which you can find more information on in these sites. I believe we'll be sending out the slides later. If you guys just want to write down your email or whatever, we can just email you the slides and you can learn a bit more about this. You can also find a ton of information on Tezos.com, the developer portal, and tqtezos.com. So diving into my favorite part of the actual network is the actual on-chain governance process, right? As I mentioned before, this is a meta protocol that can update pretty much like any network parameters in itself based on what the network and the stakeholders of the network that will be affected by these changes want down the road. So how does the actual amendment process work? How many of you guys here are actually familiar with how it works? It seems complex, but it's actually really, really straightforward. So it's currently comprised of 4 periods. Again, all of this process can also change, right? Each lasts around 8 baking cycles, which is about 3 weeks on estimate. It starts off with the proposal period where bakers can actually upvote as many proposals as they want, up to 20 proposals during the period. The most upvoted proposal will move on to the exploration vote or the exploration phase, which started off requiring a quorum of 80%, but that dynamically adjusts based on past participation rates, right? So what I think we don't want is also these massive quorum requirements. If we're actually seeing 40, 50% participation, this quorum rate actually dynamically adjusts. After the exploration vote, which also requires that quorum and a supermajority vote, we move on to the testing period where an optional test chain actually forks off. So bakers can actually bake in that test net, users and et cetera, developers can try out operations, make sure everything is set in stone and works correctly. And after that testing period, it moves on to the final voting period, right? Which again requires that same quorum, similar quorum requirement based on past participation rates and another supermajority to finally promote the proposal. So this isn't a simple process, right, to actually move a proposal from one stage to another. It's not like anyone can inject anything and it's gonna happen. This has to be a majority consensus by the stakeholders in the ecosystem to actually implement some sort of change to the network. So in total, this entire process takes about 3 months to complete, meaning that, in the case that Tezos actually wants to update itself in any simple way or any complex way, it happens somewhat quickly, but with enough time to make sure that everything functions correctly. So to give you a quick example of how this works, the first upgrade, Tezos Athens, was proposed by Nomadic Labs, a dev shop out of Paris, based out of Paris. The process went from February to May of this year, and it passed successfully and activated with massive participation from the actual bakers, right? So during the exploration vote, you had 87% participation rate, promotion vote, 84% participation rate. As mentioned before, the quorum then for the next cycles actually adjusted upwards, right? 2 big constant changes happened during Athens. Number 1 was the reduction of the roll size. So that deposit I mentioned earlier went from 10,000 down to 8,000. So it might have incentivized more people to actually start baking because of a reduction of the deposit size. And it also doubled the gas limit. Again, these were somewhat small, not small, but somewhat small, constant upgrades that actually almost tested the on-chain governance process, right? So this was mostly a symbolic proposal. Being the first, Nomadic Labs thought it'd be useful to just test out the actual performance of this process. So the network also rewards the proposers after the proposal passes the promotion period with a inflation funding invoice. Nomadic Labs just charged 100 XDZ to buy a round of beers for all the developers. But again, mostly a symbolic upgrade to prove that this worked. And what we saw is this global coordination game, right, of over 200 bakers representing over 20,000 delegates participated at an 87% rate, right? So this incredible kind of like coming together of the community to upgrade a very simple constant. If you guys want to learn a bit more about like the reflections, et cetera, you can Google this post by Jacob Arlick. Amazing recap. So what happens next, right? Babylon 2.0.1 actually just passed a couple weeks ago, the promotion phase, and we're moving from just upgrading these basic constants to more constant upgrades, small iterations to the network that in the long term are actually going to cause Tezos to always be a state-of-the-art platform. So Babylon actually dove in a bit deeper and looked at the ME consensus algorithm. It upgraded it to ME+, which added kind of like delay to preserve safety if there weren't enough endorsements for blocks. It made upgrades to Mickelson. There were some quorum refinements too. The proposal added caps, so a floor and a top and a ceiling cap. And it changed the account model to a point where TZ1 addresses, which couldn't delegate before, could delegate now. So it simplified the entire process too, where KT1 addresses are reserved for smart contracts too. So what's the big deal of all of this? Like, why have all of this in place in the first place? These two upgrades have been some of the most significant changes to a live blockchain that we've seen in our ecosystem so far, right? And Tezos has upgraded more in 1.5, a bit less, years than Ethereum has changed in 5. Now, of course, this comes with some issues, and it's not just black and white or binary. There are downstream consequences to all of the stakeholders that are building on the Tezos network, right? So wallet makers, custodians, smart contract writers, et cetera, they all have to prepare, make somewhat of an investment to adjust to that upgrade and make sure they're investing the proper resources to make sure that their product is working once it's actually promoted. But of course, this, at the very least, we know that Tezos itself and the network is actively making sure that these upgrades can happen. So what are we going to see down the road? We're probably going to see an upcoming SNARK proposal, an implementation of Tendermint on public testnet, Marigolds to layer 2 scaling solutions based off Plasma, and Plebeian, et cetera. You can learn about all of these in the Tezos forums, et cetera. None of this is actually yet being proposed, so nothing's tangible yet, but this is what the community is currently discussing as what we're going to see next for the next proposal periods, for the next on-chain governance periods. So now diving in, all of this that has been discussed so far is happening as a formal on-chain process, right? But it's really important we also take a look at the state of off-chain coordination on Tezos. Right now, it's only bakers that are voting. Sure, they're representing 20,000 delegators, but more than those stakeholders are actually going to be impacted by these upgrades, and they should also have a voice and say and stake in a lot of these decisions. What we had on Tezos and what we still have today, which is also good, is a global fragmented conversation, right? Conversations about these proposals are happening everywhere, from Slack, from Reddit, to Twitter, et cetera. Now, this also has like a lot of disadvantages. For an outsider, understanding a lot of this insider terminology is hard. Sure, it makes us less prone to social attacks from the outside, but it's also really hard to kind of like take a snapshot and understand where in the process Tezos is. And for an external stakeholder, for someone who's not a developer, not baking, but that will be affected by these proposals, it's also important that we hear their voice and we understand like where they're coming from and what their arguments are. So one big project we've been working on at TQ, and obviously in conjunction with a ton of different stakeholders in the ecosystem, is actually a governance explorer that will become a broader platform for these off-chain discussions and off-chain coordination. So starting off with just simple visualization of what the proposal is, where we're at the voting stages, and what's coming next is already extremely helpful for stakeholders that might not be as technical, et cetera, or even technical stakeholders to kind of like dive into the process and really get a snapshot of where we're at. So V1 launched a couple months ago. You get a visualization of the amendment process, a discussion forum on there, where a lot of the conversations around these upgrades are actually happening in the first place. And what we're gonna see, what we're hoping to see in V2 and beyond is actually build out this set of features that enables this to become a much broader platform, right? So we're thinking of on-chain signaling, identity, an ecosystem DAO, and different distribution through different actual channels like wallets, et cetera. So just as a big recap, why is all of this important, especially in relation to the on-chain governance mechanism, to all of this off-chain coordination? Little iterations and little upgrades of constants can be extremely, extremely valuable in the long term, right? It may not seem like a lot today, and especially given the competition of other platforms in the space, it might not be as important. But we have no idea today what this space is going to look like in 5-10 years. It's extremely important and crucial that Tezos and the network is able to upgrade via small iterations, which in the long term will allow Tezos to remain as a state-of-the-art network for whatever comes next. Aside from that, a little note on the side, TQ is hiring, and we were at the career fair, so if you guys are interested in kind of like learning more about the network, collaborating, have really cool ideas of what to build, we're always really open to having a conversation around that. So I want to stop there before we dive in a bit deeper into some of the asset standards, and we dive into some of the big value props of building tokenizing assets on Tezos, and just answer any questions if anyone has any. If not, we can just run through everything. Nothing so far? Awesome. And feel free to interrupt me at any point. We're about to hop into the actual workshop. But again, so this workshop specifically is focused on the tokenization of assets on Tezos. And what we're seeing is kind of like this emerging capital market stack appearing in different ecosystems, where you're starting to see all of these like providers and capital markets, companies and businesses really start to figure out how to interact with a lot of these systems and try to understand where the value proposition is. On Tezos, there's been a huge focus on this just because of everything we just discussed. So the on-chain governance process, the smart contract language actually acts as a very big value prop for a lot of these businesses and anyone who wants to tokenize assets on Tezos. Why? First of all, we're all familiar with the DAO hack. It's important that a platform where you're tokenizing potentially millions, billions of dollars has institutional grade smart contracts, right? So the security is extremely important in these smart contracts. And as we briefly discuss, and you'll dive in with Michael in a bit, the Tezos smart contract language is actually extremely, extremely interesting and viable to tokenize assets on. Secondly, and I think one of the biggest arguments is the fact that Tezos itself can iterate and upgrade via the on-chain governance process without the need to fork, right? Of course, the actual fact that there could be a fork is always there, and there's no denying that. But for people building, these institutional grade smart contracts on the platform, it's important to know that the actual network will be state of the art in 5-10 years. And that necessarily they don't have to decide between different forks every couple months. So continuity is a huge value proposition for a lot of these providers, and for any developer that actually wants to store any sort of value on chain, right? It just minimizes the disruption to the actual network effect of all these providers and stakeholders building on the network. So again, I think when we talk about assets, the average lifespan of assets is extremely long, right? And based on just the rates of iteration of other platforms in the space, it's extremely dangerous to store a lot of these assets on chain, assets that will last 10, 20 years if there's going to be massive forks or massive upgrades or massive disruptions to those contracts in the first place every couple of months. So that's a huge value proposition that Tezos brings forth. And as we mentioned before, the on-chain governance process is extremely special, has been proven so far, and through these small iterations will continue to kind of like outlast a lot of other networks. So with that being said, if no one has any questions, we're going to start diving into some of the asset standards with Michael, and then dive into the awesome workshop we have prepped. Thanks, guys.
Hello, I'm Michael Klein. I work at TQ Tezos, and I'm going to explain FA121, which is the ERC20 work-alike on Tezos to represent a security token. And then we're going to dive into the actual workshop where hopefully you'll be able to trade your new FA121 token that you'll be making all the way up to tacos. And on that previous slide, you saw it was 235 years for BNY Mellon, but I think tacos have been around a little bit longer. All right, so what's a fungible asset? Fungibility is the ability of a good or asset to be interchanged with other individual goods or assets of the same type. You might think US dollars or tacos that are all made exactly the same or something like that. And to represent this, in Ethereum, we're familiar with ERC20. So in ERC20, we can get the total supply, how many tokens exist, how many tokens does an individual person have, transfer tokens between people, possibly with a from address if maybe we're authorized to transfer for somebody else, approve somebody else to spend our tokens, and actually check how many tokens you're approved to spend. So FA121, the fungible asset standard 121, is very similar with a couple extra bits of functionality that are often added to ERC20. And those are minting and burning. And then convenience, see who actually owns this contract. When we're going through the workshop, you will be the administrator, you will be minting some tokens, and then trading them with other FA121 tokens to eventually get to tacos. So that was supposed to say taco truck, but so here's the idea. We have a stable coin for tacos. Users receive vouchers from vending machines and may spend them on tacos. They have some sort of card that represents their wallet. We have some sort of vending machine or cashier that have rolls of vouchers, and that's how we mint new tokens. Users buy from the vending machine and they get new vouchers, and that's transfer. They can swipe at a payout counter or the taco truck to check their balance and make sure they can actually buy a taco. And finally, they can burn the vouchers, getting real tacos. So what are some of the issues that we might run into if we're just doing a basic FA121? Off-chain is probably where we're gonna have some server that is running the vending machine. We've got some sort of point of sale for the taco truck. What could we run into? Well, one thing is maybe our accountant wants to know how many tacos we're selling. So off-chain, we could just query all the transactions and check, okay, well, here's the ones that represent money that our accountant actually wants, and then collect those into a spreadsheet. On one hand, there's no gas required, but we do have to traverse like most of what's happened to actually find where are our transactions. And we could use an indexer, which is basically just mirroring the blockchain in a database for faster queries, but that adds additional complexity. On-chain, you could add a callback to the burn operation, so every time you burn tokens, it sends a message, and then we could collect these messages into a spreadsheet likewise. But that could definitely cost more gas. So it's really a trade-off depending on how many are going through and how much you want to spend on gas fees. But we could also have vending machines running out of vouchers. So off-chain, you could go up to each vending machine and say, okay, do you have enough? Are you running out? Just like somebody going around to vending machines and refilling them. But this might require like polling, which is analogous to walking up to the machine and saying, okay, are you empty? You don't exactly get a notification on your phone when it happens. On-chain, we can similarly make a callback, and that's how we could actually have some sort of way of getting a notification on your phone when it's low. But there's different pros and cons depending on how you do this, and maybe you end up with an unlimited number of vouchers and then you run out of tacos, and it can get a little bit tricky. And then, like that exact example, what if we run out of tacos and we have a lot of vouchers left? Well, off-chain, maybe we only make vouchers when we make tacos. We make 100 tacos and then we distribute a bunch of vouchers to the vending machines. But then it becomes a lot harder to manage both vouchers and tacos. And then, we could always do more stuff on chain to try to do some resource management, but we're just kind of pushing dirt around. We're not really solving the issue. It's just moving it somewhere else. Maybe also we have unclaimed vouchers. We could just query the token and burn anything that's unclaimed every once in a while. Or likewise, we can add some sort of logic on-chain, but that would definitely increase the fees to anybody who interacted with it. And then maybe people lose cards. So Kevin mentioned the need for identity and authorization management on Tezos. This is definitely something that we see in a lot of blockchain platforms. And in some sense, there's really the two ways. You either have a very central source of truth. Who are you? What is your account? And then a user could say, oh, well, while you stored my single source of truth, you stored my email address and my phone number, my passport ID, whatever, and so I can later verify who I am and recover my account. And on-chain, it definitely gets a little bit complex because how are we actually securely storing the recovery method? And that might end up, maybe we have some sort of multi-sig solution with a backup wallet. Maybe we have some sort of recovery method built in, but definitely this is something to figure out. Maybe users have a bunch of voucher cards and they want to, maybe I have one voucher on one card, another voucher on another card, and I want, a bunch of tacos. Well, maybe you could just spend in series, or maybe you could actually let people spend from other people's wallets, just like we have the allowance. So you could say, oh, well, I have, 10 taco vouchers, and I'm gonna allow you to spend up to 5 of my taco vouchers. And, maybe 24 hours later, I'll make that 0 if you didn't actually spend them. Oh, and then, so this is the last one. What if people start kicking the vending machines and trying to get free vouchers? Well, off-chain, you can try to make it a little bit more like an ATM and make them really heavy and all that. But, that could be costly. On-chain, there's a fun idea of using zero-knowledge proofs to actually say, okay, we know that the person walked up. We have, maybe a screenshot or like a quick image of them walking up to the vending machine. We know they pushed these buttons, and we can store that as a witness that somebody actually interacted with the vending machine properly. And that witness can be required with proofs for actually receiving your vouchers. All right, thank you. Any questions for this quick section? No? All right. So, the workshop, the goal is you will be originating your own FA121 token, and you will randomly be assigned to one of these, the lowest level on the tree, and you will have to trade at different exchange rates up to tacos. So this is the diagram of all of the tokens that are in this setup, and they don't have very fancy names, but this will be in the repo that you'll be cloning to actually run the workshop. All right. So the workshop itself is at tinyurl.com/Tezos-SFBW19. Just a quick show of hands. Did any of you do the setup that was sent out in the email? All right. Well, great, because it's changed. All right, so first you'll be using Brew. So if you're on Linux, you'll need to get Linux Brew. But I have pre-built binaries both for Mac and Linux. If you're on Linux, I'm sorry, it will take a long time to build. So you can run, can everybody read this on the screen? Yeah, all right. So you'll brew tap into the repo and then install Tezos, Lawrence contract param, and Lawrence contract sale. Lawrence contract param is a tool to generate initial storage and different operation parameters from human readable text to Michelson for different Lawrence contracts. Lawrence is a tool for making smart contracts in Michelson with Haskell. And Lawrence contract sale is a similar tool specific to the sale contracts that we'll be using to actually trade tokens. You'll definitely need Ruby. This was made with Ruby 2.3.7. It's a little bit of an older version, so you should be compatible with pretty much any version. And then you'll need to actually get the sale token files and the Lawrence contract originate script. which you can get by cloning this repository. Once you're in there, you'll go to Originations and Taco Sale and remove the existing Originations file, but I believe it might actually already be gone, and this is out of date. Let me check. The user taco sale should be out of the repository. Okay, and then here's the step that will take another minute or two and will require some interaction on my side. Send an account request to michael@tqgroup.io with subject SBFW new account, and I will send you one of the pre-made accounts. I've got 50 ready. They all have about 100 to 200 Tez, and that should be more than enough to actually start originating your contracts. And if you're waiting for stuff to install, definitely consider sending that email earlier so I can get them all done. And let me know if you have any questions at any time. These are all in a sandbox, so.
Yeah, the people's emails in the two line are.
Oh yeah. Well, yeah. All right. So once you get a public-private key and whatnot, you'll need to add it to the Tezos client, .tezos client files, and that's where the Tezos client will look for the account. So then you'll be able to say things like Tezos client transfer from your address to some other address, and it'll automatically authenticate you. So once you have an account and everything is installed, you'll be running something that's kind of like halfway between a Docker file and a make file. So let me just pull it up real quick. So usually when you interact with smart contracts, originate new contracts, perform transfers, actually call a smart contract, you're running these Tezos client with your node that you're using and putting in each of the parameters manually and whatnot. This is, like I mentioned, something kind of like a cross between a Docker file and a make file where you can declaratively describe what you want to happen as far as originations and contract calls, and it'll run through all of them, make all the names that you can reference, and it's idempotent. So if it crashes at some point or you have an error, it will not try to rerun everything you've already completed. So here you can see we have a base configuration that has a path to the Tezos client already with the port and address. You have your user address, or here this is the administrator user address, and paths to Lawrence contract param and stack. Though, if you look in the taco sale user file, which you'll be originating, it doesn't have, or it shouldn't have, a param path or a stack path for your user. And that's because you'll be installing a globally installed Lawrence contract param and Lawrence contract sale. So just quickly going over what this looks like, you can declare a user with a name and an address. You can originate a new contract specifying the burn cap. This is the maximum amount of Tez that you can spend on gas. You definitely need to set who the administrator is because that's who's allowed to mint and burn tokens. And then we have the command to actually print the contract and the command to print the initial storage given the parameters. So these will be converted to Michelson, and then it'll all be wrapped into a command that goes like Tezos client, and then your port and the address of the node, transfer from your address to the contract, et cetera, et cetera. So here we have a bunch of tokens. These are all the basic FA121 tokens. And then for each token, we mint somewhere between, I believe it's 100 and 3,200 tokens to the administrator. Once these all are minted, we actually get to the sale. So I didn't have slides for the sale, but basically how it works is you allow the sale to spend the tokens that you want to sell. And then you set a price, and then somebody else can say, okay, I accept your price, I want to buy 10 tokens at 1-to-1, so I will make a purchase. So first I allow the sale contract to spend my tokens so that it can transfer my tokens to the seller, and then I call the contract and it will perform the transfer. And that's what we'll be using to actually trade up to tacos. So each of these has an administrator, the held token, which is the token being sold, the wallet where the tokens will be, the wallet of the seller that is currently holding the tokens to sell, and the address of the wanted token. So a token 1 and token 2 are contracts, Alice is the administrator address, and then here we have the held price and the wanted price. So I'm selling one token for I'm selling one token 1 for 2 token 2s. All right, and then as you can see, after you have all of the sale tokens, I actually set up an allowance for each of them so you can actually buy, and the allowance should be the maximum so that there should be plenty of tokens to buy and sell. And that's about it. Let's see. All right, 1 second. All right. So once you have your keys and they're set up in the Tezos client, you'll need to edit the configuration file in tacosale_user.yaml, and you'll need to put your address in the user address field. Additionally, in the user field, so that's, let's see, so tacosale user. So here's the address field where, oh, screen's down. Thank you. All right, so here is the address that you'll be replacing with your address. This is the address that you just got. And you won't have a token yet, so you should just get rid of that. And then Bob is you, or you can rename Bob to your name. And this is the second place to put the address. Once you've done that, you can run this script using // Lawrence contract originate taco sale user .yaml. And this will make your FA121 token. It will give you, it'll mint tokens on that token for your account. And then it'll update this file. Well, update taco sale user.originated. So let me actually, let's just try running this. That is the Mickelson version of the contract that's generated by the command line tool. And this is attempting to originate a new FA121 token called token Bob, transferring from, this is the my Bob account. And you can see the initial storage. Right here is the big map, or the ledger, that contains everybody's balance. Starts out with nothing because nobody has a balance. This is the administrator address. This is whether it's paused. For regulatory reasons, we definitely need to be able to pause these tokens if they represent like a security or whatnot, for auditability and similar purposes. And then this 0 is the initial amount of tokens on the contract, because initially nobody has any balance. And then you can see it takes about 4.6 Tez to actually perform this origination. So give this a second. All right, and then this should already be generated. So this will have an exact copy of the configuration from your taco sale user file. And that's to make sure that if you ever change your configuration, really you should be rerunning everything. But if you don't change your configuration, most things shouldn't need to be rerun ever, because all of these should be one-time operations. You create a contract once you've created it, you don't need to create another one. You mint tokens once, and there's a name to deduplicate. So maybe you want to mint twice, but still it'll need 2 different names. And so on and so forth. All the setup should just be performed once. And then here under originated, this hasn't finished, but originated will have the address and the configuration for any contracts you originate. And the RAN will have all the operation hashes. So you can go and actually check, like with a block explorer or whatnot, you could say, okay, I found the exact operation, here's what happened, I sold these tokens or whatnot, but I can, give that to a user or an end user, and they can see it in a very graphical, friendly way. All right, so let's see this. So this said it timed out. Have any of you succeeded in running this? This might end up being.
I'm stuck in stack at this stage.
Okay. It didn't install the bottle? Okay. Are you on the latest version of OS X? Okay. Yeah, so the bottles are only built for latest version of OS X and one of the latest versions of Linux, which is Debian based. So yeah, it takes some time. Yeah, it's building Morley, the Haskell Mickelson library, and that for some reason uses lenses, which I'm not sure if you're familiar with Haskell, but there's many, many dependencies. It's kind of like a batteries included for Haskell. So I'll rerun this and then check with my coworker who was working on the sandbox to make sure it was up. believe that I might have not updated this and it was on the old node or sandbox. So I'm just gonna update this real quick. All right, yeah, that's working now. Let me just push the update. All right, so yeah, if you refetch, or if you fetch the latest commit from master, that should work. All right, and then this will eventually fail, but in this case, it's actually failing for the wrong reason, which is that I gave it an invalid account. So I will also beat up using an account. Let me just use the last Bob account. I'm just now editing the .tezos client file that has all the keys to add my new Bob account. Yeah, one sec. I just had to edit the keys. All right. So now I will add some tokens. All right, so add some tokens to the Bob account that I just started using. Let's see. And this should already be done for each of your accounts. And you can see it costs about 2 Tez cents to mint, or to transfer 100 Tez. All right, so then that should be ready. And I can retry originating the contract. Let's see what we got. Transactions of 0 to a contract without code are forbidden. Let's see. So it looks like we successfully originated the Bob token, minted 100 tokens to Bob's account, and created a sale. Okay, so after this point is where you need to register your account so that you can actually perform a sale. So to do so, just send me the entire taco sale user originated file. And this will contain all the contract addresses that you've originated and with subject SBFW new token. Once I get that, I'll create a sale and you'll be randomly assigned one of the tokens at the bottom of that tree. Let's see, do I have the tree? Right here. You'll randomly be assigned a sale to one of these at 1-to-1, and then you can trade. So for example, let's say you start at 31, you can trade up to 15, then trade up to 7, trade up to 3, and then finally trade up to the taco stablecoin. So once I get that, I'll run a quick script on it, and then you'll get this sale token 17, for example, or 30 or whatever, and this is the rate, which is 1-to-1, and this will be the name of your token. So it might be slightly mangled, but it will be roughly the name that you provide. Yes?
So I'm still building Tezos. Can I install the contract params and edit them while it's still building?
Yes. All right, once you get that, since these YAML files allow you to simply declare users, and users and contracts are really both a type of user address, you can simply copy and paste this into the do section before the first failing operation. So in my user YAML, this would be right here. So right after I have the mint token, that's where I would put the sale that I'm authorized to actually use. To perform a purchase, first I have to set an allowance on the sale contract to say that it's allowed to accept my or to transfer my tokens. And here you can see I'm allowing it to spend up to 100 of my tokens, which is everything. Then you can run a purchase operation, which needs to be named, and you specify the contract of the sale, and then you confirm the price. So if somebody changes the price in the middle of you trying to run this operation, it won't, for example, maybe I say, oh wait, I said it was 1-to-1, but actually I'm charging, 100 of your tokens for one of the tokens that I'm selling. If that happened, you would get an error instead of it actually just spending all of your tokens. Basically, it's kind of like you're checking out and they can't change the price as you're checking out. Once you've run that, you'll have completed the purchase, and then we can actually check and, sanity check, okay, how many tokens do you have in your original token account? How many tokens do you have in this new token that you just bought? So we can originate a natural number storage contract to actually receive the balance. And then you can say, okay, well, let's make this nat storage, and then make two, really. You want one for your token to see, how many are left. There should be 99, and then one for the token that you just bought, that you should just have one. And then we can actually run get balance on the FA121. And this is just really specifying the contract, the account that you want the balance for, and the contract that will store, the natural number contract that will store the balance. All right, and then I believe there's a nice way to actually check that balance once it's been put in that contract. Let me see. All right, so if you run Lawrence contract param or Lawrence contract originate info and then the file instead of just the YAML file, that will check the storage for everything. So here I'm going to run it on taco sale. And then actually, yeah. apparently the info command doesn't work. So instead, what you'll have to do is run the Tezos client directly. So get contract storage for, let's see, let's check it for the FA121 token that I just originated. And we can see here's the initial storage. It has 32, well here, a total of 100 tokens. I believe this is the counter. This is the administrator address, and it is not currently paused. So let me add this to the guide real quick. All right. So once you actually have the sale, you'll be able to continue making trades all the way up. So let me just go back to the diagram. So for example, maybe you get 24 as your randomly generated sale. That will be a 1-to-1. And then to get to 12, it's gonna be a 2-to-1. There's a doubling as you go up the tree. So for example, you could say, okay, well, I'm gonna trade 1-to-1 to 24 twice and then trade to 12 once. So you could only set the allowance once because you're just gonna allow it to transfer any of your tokens. And then each purchase will be a 1-to-1, a single token for a single token. And then you'll be able to do this once and actually get a single 12 token. If you do that process twice, you can get a 6 token. And if you do that process 4 times, you can get a 3 token. And then copy and paste it one more time, and you can finally get a taco token. Any questions? Are most people just waiting for it to build? Yeah? Should have made more bottles for different versions, I guess.
What's this Lawrence contract param thing?
So Lawrence contract param is a tool that I made to interact with Lawrence contracts. So Lawrence contracts is just the name of all of the Haskell contracts because that's the name of the tool. So this will generate, alternatively, the initial storage of the contract itself, or any parameter that you need to actually call a contract. So how you call a contract in Tezos is you have the contract address, you transfer some amount of Tez, usually 0, and then you give it the type, or like a value. And so let's say we have 3 parameters that things we could do. That would be like either thing A or thing B or thing C, right? Like a sum type. So you would send that value, which represents which parameter you want to call, to the contract, and then it'll execute and update the storage.
So how do we install it without proof?
You can install it from Git. You can go to github/tqtezos/Lawrence contract param. Actually, this might be faster for some people that are waiting, and it shouldn't interact if you're just waiting for brew, if you want to do both, if your computer's not already at max. So you can just go to, like I said, github.com/tqtezos/Lawrence contract param and do the git clone and then stack build, stack install. If you want any more details for that, please let me know. So I'll just, I guess, show you a little bit more about the Lawrence contract param and Lawrence contract sale commands directly if you're not using them with this YAML tool. So Lawrence contract param, they all have verbose help commands, so you can check all the things that you can do. So you can, this is to generate parameters for a Walker contract, multi-sig contract, managed ledger Athens, which was the Athens version of this FA121 contract, the Babylon version, which is the one that we're currently using. You'll see managed ledger Babylon approve and get balance and mint if you look in the YAML file. Because this is just calling Lawrence contract param directly. And then if we go into one of them in particular and we say, okay, well, what does that actually take to transfer? You can also run help with that, and you can see, okay, well, we need a contract address, a counter, from and to. Well, this is for the Athens version, so it's slightly different, but value and signer keys. This is for multi-sig. If we just want to generate the contract, we can use Lawrence contract, and this allows you to list all the contracts it supports. And if we, for example, want just the natural number storage, let's see, nat storage contract, we can print it. And that's what we get. So if you look here, you can see that in contracts in Tezos have a parameter, a storage, and then some code. So here the parameter is just natural number. The only thing you can call it with is a single natural number. The storage is a single natural number. That's all we're storing. And then the code, we drop the existing storage. We say we have no side effects, and then we bundle no side effects with the new natural number that we're storing. So if you call it 3 times, it'll have the most recent value that you stored. And this is useful because in Tezos, unlike Ethereum, you can't actually have a return value for a contract call. All contract calls have just side effects and storage updates. So let's say I want to get balance. How you do that is you have a parameter where you provide a contract address, and that contract address will receive the balance. So here we're just storing it so we can check it later. But for example, when I mentioned like the minting and birding callbacks, where you could actually do some extra logic, you could just provide an address and it would call when running. All right, and then I'm going to continue with trying out this demo. So let's see. So I'm running Lawrence contract originate on the taco sale configuration, and I see that everything's already originate. We have a bunch of sale tokens, bunch of mint tokens. There should be 31 individual different tokens in the binary tree where you can get up to tacos, where token 1 represents the tacos. And all the mint operations and all the allowances. So then if I check for taco sale user, we get that, well, it stopped because we don't have the latest sale. So I will make a sale for this user. right, and I have this script that once you give me the originated YAML file, it will automatically generate a sale. It'll randomly select which sale you'll get. It'll generate the sale contract, and then it will run this, giving the allowance to the sale contract so you can actually buy tokens on the seller's side, which is my side, and then you should be good to go. All right, this might also need to be updated. This needs the new one. All right. Now it's just complaining that I've changed the configuration, which of course I just did. And then I can rerun, and this should work. All right, so it looks like it successfully made the sale contract, made a new contract called sale token 24 to token bob11. So you can see it randomly selected the 24th token. Let's just double check that that's where we expected it to be. And we can see, yeah, 24 is on the bottom layer, below 12, 6, 3, and 1. So this will then generate this field, the name of the sale and its address, and that can be copy and pasted to your taco sale user right here. So I'll need to update sale token 17 to sale token 24. And then this should be ready to run. All right, and it looks like that completed and was able to get the balance and make the NAT storage contracts for the old and new balance, and then actually check the balance. Let's see, where did it get? Aha, so I believe at the bottom, let's see. So we have the sale, post-sale balance, mint, call the sale token, and then call the purchase. And it looks like the purchase completed. And we can check that here. So I need the client, and then I can say get receipt for. And then the operation hash. And then of course you want to actually see that the transfer completed. So I'll use this command to get the storage. And first I'll get the storage for this user's token, and then token 17, and then for this user's token. So for token 17, this says the balance is 0, which is not what's expected. And the other one also says 0. All right, let's see, what do we got? Aha, it never called get balance. So while trying to call get balance, what do we get? So we want to run get balance with the account Bob and the callback contract. Post sale get balance token 17. Aha, it's trying to get balance on token 17, and we're now using token 24. All right, so that could be a rerun. Yep. Port is not open. Yeah, let me.
No, I mean the EC2 client I'm supposed to connect to
Uh huh.
is not connected.
All right, let me just take a look at that. I'm not familiar with that message off the top of my head. Yeah. So let me make sure I push the latest version. But yeah, that looks like it's the wrong address to the sandbox.
Oh, is it?
Yeah. Do you have the latest version of master?
I thought I fetched it again. I'll try it again.
All right. Aha. So I found here that I also need to add the user for token 24. All right, and then it looks like that's working. I was able to find token 24, and if we check here, it was able to get the balance for token 24, and then, let's see, where did we get? Oh, and then it's complaining that it wants the address explicitly, and let's see. It wants a burn cap. that's a little bit higher than all zeros. And then as you may notice, after you perform any operation, you're not guaranteed that it's instantly included. So Kevin was talking about baking. How it works is you propose your operations to be baked, and that comes along with the expected amount of gas and fees that you're willing to spend to have it be run. And then it will be randomly assigned to a baker based on how many rolls, that is, how much steak that they have. So for example, if you have 1% of the steak, you have a 1% chance of receiving the next operation. Once they are selected, the operations are all put into a block, which has a maximum size, and then they're run. And then when they're finally committed back to the blockchain is when we can actually use the results in another contract or get the balance or whatever else. So a lot of the glue code in this script is actually making sure that everything completes, retrying things if they fail, and fetching all of the addresses and operation hashes that the Tezos client will emit. If you're not using something like this, it does require a fair amount of copying and pasting these addresses and hashes, especially if you have many contracts that interact, such as the binary tree of sales. And it looks like that completed, so I should be able to find the balance for how many tokens after the purchase. So this should be how many tokens I have on token Bob. I have 100. And then how many tokens I have on token 24. And I have none. Yeah,
So this is all just happening in the sandbox, it's not on the testnet?
that's correct.
Okay, but if it was on the testnet, would we be able to see all this with the Explorer?
Yeah, and you can actually set up a block explorer with the sandbox, but we haven't. Also, I should mention that in this sandbox, operations run and blocks run about 10 times faster than on a testnet, which is, for a workshop where if you had to run everything on the normal speed, it would take probably an hour or two just to run. And then the testnet also is twice as fast as mainnet. So if you're doing a very large number of operations, first of all, you're probably spending a fair amount of gas. I mean, I gave everybody about 100 to 200 Tez, but you could easily go through that originating the 60 contracts I have in this example. Yeah, so let's see. So if you see here, it has Tezos client -A, EC2-3-133, blah, blah, blah. Just make sure that that's the right address. Because as I mentioned, I woke up this morning to the sandbox being down and had to switch it all over. Yep.
Yeah, I guess I gotta change that.
And then if it complains about the configurations not matching, just delete the taco sale user.originated.yaml because you won't have anything in there if it hasn't done anything. But the other solution is you actually have to go into the other one and edit it as well, which is more work. Did you edit the .tezos config file in your home directory? Then let me take a look. So what we ran into just now was that here you see in public keys, there's actually two places you have the key. And notice that it's edpk for ed public key in both cases. So you need the public key in both fields.
I'm getting the same error, but I can't figure out where I'm missing it. First I wrote Tezos client without the dot in front, so then I changed that. Missing something somewhere.
Where are you in the guide?
Same place, same error. No keys for the source contract manager. I'm trying to figure out what I did wrong with those files. Yeah, I'm still getting the same error.
Still getting the same error. All right, let me take a look and try to debug this. Hopefully figure it out for both at once. Oh, okay. So do you edit the taco sale user file with your address?
Yeah.
In both places? It's also yeah. Oh, it appears that we may have to just tell the sandbox that your account exists. Even though the account already has Tez, apparently you might be able to have Tez and not exist. So let me get the command for that real quick. Okay, so my coworker says that you should be able to take that transfer where it's from one to the other and just make those both your address, and that should work. Michael at tqgroup.io. TQ. .io. If you send me something right now, I can confirm it. Cool. All right, I just got it. Yep. Nothing? Same error? All right, let's see if I can find. All right, can you try reveal key for and then your address? So the whole Tezos client all the way up to -P 20,000, and then I have it up on the screen, reveal key for space your address. So at the bottom here, here's the Tezos client command, and then space reveal key for, and then the address.
What do we put before reveal? Tezos or something?
Yeah, so at the bottom of the SFBW workshop, I have the Tezos client command for the server.
I'm sorry, what is the review key for, and then what?
Reveal key for space and then your address. The public key hash should be TZ1 something something something.
No contract or name.
Okay, let me see that. Mm-hmm.
If I need to enter other names, or you tell them I exist.
Let me see. I'm gonna try giving you a different way to tell the client your keys. Yeah. Mm-hmm. Yeah, yeah. Oh, cool. Okay. Yeah, yeah, sure. I have my email up. Just send me an email. I'll go at TP Group. TP Group. Mm-hmm. Yeah, I should be here this afternoon. Yeah, yeah, just let me know earlier because, like, otherwise I might schedule something, you know? I get out of this around 12:30, probably 1:30 would be good. Sure. Alright, cool. See ya. All right, I figured out the fix for the wrong address. So you'll need to run the Tezos client bit and then import secret key name and then your unencrypted private key. So I'll add this to the bottom of the workshop markdown. And that should completely convince the client to recognize your key.
So an important secret key, and then, so I didn't change the name, so I'm still Bob Test then.
This doesn't matter. You're still going to be referencing the keys by like the public key. So this is just for the client to have a reference.
So it's the bottom line.
Yeah, and make sure you keep the unencrypted and keep it in quotes. Single quotes or double quotes should work. Just want to make sure that Bash doesn't try interpreting your key as a command.
So, and we put in, we're typing private key there.
Yep, EDSK for secret key. ED is the cryptographic curve. It's ED, what is it?
Yeah, I see it says secret key.
Yeah. I always forget which curve is used. It's the ED 25519 curve. So that's the ED, and then, yeah, SK for secret key. Did that work?
No. I might have done something wrong, but now it says error will parse it. SKURI needs a scheme.
Oh, you made sure it has the unencrypted colon?
No, okay, that's it.
That's it. Yeah, I got that same error. Were you able to run this? Or you got? Oh, you did run the reveal.
No, I tried to review.
Sorry, the import. Sorry, this is the new.
Yeah, I did put the.
And that worked?
It says it's imported.
That worked.
Yeah,
And then what happened when you tried rerunning the?
it says no password.
Can you rerun it real quick? Maybe like there was a time constraint or something. Or yeah, let's just try the transfer. Yeah, go down because it's transfer one. Yeah, yeah. No keys, which is your contract manager. Wow. Alright.
It's actually complaining you cannot import it, so I need to use force.
Oh, cool. That might actually fix it.
I'm gonna go sit over here because I think we're like.
Yeah. Save some time, yeah.
Yeah, I got the same thing where it still said no contract
Uh-huh.
for that key after doing
The import.
successfully the import.
So since we're kind of running low on time and it looks like we might not actually be able to get a complete run of this, I'd just like to mention that if you change where the Tezos client is pointed to in this, well, the taco sale user file, so you can put, Tezos client, and then here you can put like a testnet node on this line, and then on this line, and then on this line, etc. And you should be able to rerun taco sale and originate it on testnet and run this taco sale user and run that on testnet. And if you're making a testnet account with a faucet, then a lot of these account details shouldn't really be an issue. So you can just go to, I'll add this to the workshop markdown, faucet.tzalpha.net, and you just click get alphanet tez and they give you a JSON file. And this JSON file can be directly imported into the client. And this is very well established as far as adding accounts. It works great. But you can't use it for a sandbox because we haven't set up a faucet for the sandbox. So let me just add this link, and then a link to some additional details on how to set up the client. All right. They originated, yay! Perfect timing at the very end of the talk. Well, you guys have won tacos, even though you didn't get to the top. Or our taco, not equivalent, but almost equivalent, which is the merch that we have over here. Please feel welcome to grab whatever you like on your way out. I think we have some cozies, some t-shirts, maybe, bottle openers or pens or something. And then does anybody have any closing questions or remarks? Yes?
What will happen, what I see the token standard is more ERC20 like token except mint and burn.
Mm-hmm.
You have added.
Yeah.
What happened in case of the regulated environment?
What happens if, sorry?
In the regulated environment, and like if the token is need to comply with the regulation, where you do the regulation,
So,
design a new token standard for regulated.
all right, so that's a great question, and I'm not sure if you were here for an earlier part of this talk, but I kind of compared and contrasted some of the on-chain and off-chain, whether or not you want the logic on the contract or off the contract. I would say that most exchanges will likely do a lot of this off-chain. So what you'll do, for example, is you'll say, okay, your account when you create it on the contract is not approved, and then somebody has to manually approve it, the whole KYC process. And then after,
It's different, I'm asking, because as soon as you do off-chain, your ERC20 contract, atomicity, you need to maintain, right?
right.
So if we do off-chain regulation, how do you maintain the atomicity of ERC20 contract?
So if you're doing all of it off-chain, then likely you are simply promising that the on-chain version represents what you've stored off-chain. On-chain, you could encode more regulatory logic. I mean, pausing is really just the minimum saying, okay, well, if the SEC comes knocking at your door, you better be able to pause the contract, right? But there aren't other very similar regulatory things if you don't know what the asset represents. So if you do know what the asset represents, you say, oh, well, This is something that only can be purchased by an accredited investor, and they have a minimum investment and a maximum investment. You can add that logic to the token contract and, crash whenever somebody tries to violate it.
Yeah, so how do you trade off between on-chain, off-chain, offline?
Really, you really have to look at what the gas fees will look like, I would say. And then just the simple fact that the total gas limit for any transfer or contract call is relatively small compared to running a program. It would be probably milliseconds if it were a C program. So if you exceed that size, you really can't have it on chain. So really it needs to be small enough that you can fit inside the gas limit, and then low enough cost that you're willing to pay for it.
Yeah.
But many people will instead simply, like I said, do off-chain and then maybe like a hybrid where they store a witness value on-chain, some sort of guarantee that you can publicly access and say, okay, I know that it's much more likely since I have this data that it was actually checked.
So you are saying basically during that, because the token is a lock, that you can check token is locked or not locked on chain, but for the logic you can do off chain.
Right, exactly.
Right?
Yeah.
So the trade-off.
Any other questions? All right, well, thank you all so much for attending, and I'll see you at the rest of the event. Have a great day.